We're going to start today with DMA80, Section 1. DMA80, we are going to be working with what's called radical expressions. So we'll work with radical expressions at first, and then we will get involved with solving radical equations. If you think back in previous modules, let me just start with something really simple. If you have 5 to the second power, you have a base raised to the power of 2. 5 squared gives you the number 25. Back in, say, DMA 40, when we were learning beginning algebra, the opposite of adding was subtracting, the opposite of multiplying is dividing, one undoes the other. In this situation, when you have something that's raised to a power, the way to undo it is in essence to take the square root. The sign that's around the 25 is called a radical sign. So if I were to ask you what is the square root of 25, technically that means we have 5 times 5. And since we have a pair of 5s, the 5 then comes out from under the radical, and that solution would be a 5. So when you raise something to a power, like squaring something, taking the square root of it would be, in essence, the opposite to undo it. Not everything is going to be a square root. We're going to have other indexes like cube root, fourth root, fifth root, any kind of number we can use as a root. When we simplify a radical expression, it can involve variables as well as numbers. So sometimes we'll have x squared, y to the 16th. We will have variables as well as numerals. It's important to realize that when we are dealing with roots, that we have to deal with what are real numbers. And for the most part, when we're dealing with a square root per se, or an even index, we are looking for positive answers. If it's not a positive answer, if it's negative, then that will be considered a non-real number. Okay, so let me give you a couple of examples of these. If I were to give you, let's say, the square root of 49, that would mean we have 7 times 7. Since I have a pair of 7s, the 7 comes out from under the radical. So my solution is just a 7. If I have something written such as this, an opposite sign out front, and then the square root of 100. Notice that negative is not under the radical. What's under the radical is the 10 times 10. There is a pair of 10s, the 10 comes out. Since this radical is in front and it's not under the radical, that answer there would be considered a negative 10. However, if I were to give you this, a negative 100 underneath, this would technically be negative 10 times positive 10. There is not a pair of matching numbers, so the answer for this, we would say the answer is not a real number. Now let me forewarn you, because I don't ever want you to think I'm telling you a story. Eventually, we will talk about how we can simplify this, and later on, we're going to use something called imaginary numbers to represent a solution. So let me just put a note here. I'm going to say later we will talk about imaginary numbers. For all purposes now, in this first couple of sections, if you're asked to give an answer, then you'll just say the answer is not a real number, and that's going to be the end of it. But later on, we're going to come back and learn how to deal with there being a negative underneath the radical. Okay, what if we had, let's say, under the radical x to the 10th power. Now, normally, I'm not going to normally make you write out that many x's. You wouldn't only have to write out 10 x's, but I just want to show you. For every pair, one x is going to come out. So how many pairs do I have? 1, 2, 3, 4, 5. There are 5 pairs of x's. So what comes out is x to the 5th. Another way to think about that is we do not write the index of a 2. I wrote it in yellow here. We never write a 2. But if you say 10 divided by 2, that would give you a 5. That's how you're going to come up with the exponent when you're simplifying a radical expression, is by doing a simple division there. Okay, let me give you a couple of examples, and these are ones that you'll find on page 8-6. We have the square root of 81, the square root of 16 over 49, the square root of 36b to the 8th. We'll start with these. Now, if we do these longhand, 981 would be 9 times 9. You've got a pair of 9s. That will be a 9. For this, we have 16 is a 4 times 4. 49 is a 7 times 7. You got a pair of 4s, a pair of 7s. That's 4 7s. For this, you've got 6 times 6 is 36. And then you would have, I'm just going to write b to the 8th. So you got your pair of 6s. And if your index is a 2, 8 divided by 2 is going to give you a 4. We've not looked at the calculator yet, but let's do so. In order to get the square root sign, you would press second and the square root, the x squared, so we're activating the little blue here, and we type in the 81. That gives us our 9. Okay, we can do second square root, and we can type in, I'm going to do alpha y equals number 1. Whoop, hang on. Let me start that over again. Hit something wrong. Okay, second square root, and then underneath, there. Hit a wrong key. We got 16 over 49. Come out from under the radical. There's our 4 sevenths. And we can do the square root of 6, and that will give us 6. A minute ago, I did the square root of 100. Whoop, 100, and we had the answer 10. If you were to type in the square root and you put a negative 100, I want you to see what you're going to get. You get an error, and it tells you there is a non-real answer. So if you're keying this in on the calculator, you're going to see it's going to give you the non-real for a scenario such as that. There are other ways to get to the square root signs and so forth. If you press the button Math, if you look down at number 4, you have one for the cubed root. If you go down to number 5, we have one where you can type in your own specific index, because you will be given problems with different indexes from time to time. So let me come back here and let me show you that. So the number that goes underneath the radical, we call that number the radicand. The numeral that would be placed here in front is called the index. It would go in that little location here. The symbol that is drawn around is called the radical sign. When the index changes, what we've done so far have been square roots. When it changes to a different index, then that means the number of times your value is repeated is increased to that number also. We're going to be looking in a moment at, and you've got a chart in your book on page 8-7, page 8-7. You have a chart on this page for square roots, square cubes, the perfect fourth powers, and they give you the more commonly used ones. They're the smaller values that you would normally see. So if, for example, we are given, let's say, the cubed root of 64, and we want to simplify that. Now, we all know that 8 times 8 is 64, but this is not asking for a square root. If we had 4 times 4, that gives us 16, and 16 times 4 is going to give us 64. The answer for the cubed root of 64 is going to be the number 4. So let me show you how you can key this in on the calculator. There's a couple of different ways you can do this. One way would be, since it's a cubed root, I'm going to press the number, I'm going to put here calculator steps. Now these steps here are going to work, calculator steps to work with perfect roots. If it comes out evenly, this will work for you. I'm going to press the number, so I'm going to write here index, and then we're going to press math, and then we're going to choose number, and I have to look at the calculator for this. So we're going to press 3 for the index number. I'm going to press math, and then we're going to choose number 5, the one that has the X here. So we're going to choose number 5. Choose number 5. 5 is the one that has the X, the radical, and the blank here. And after that, you then type in the radicand, that number that's under the radical. Okay, so start over one more time. 3, math, 5. So now I've got the cubed root, and I can type in my number 64. My answer is 4. If I wanted to do the cubed root of 125, I would do 3, math, number 5, type in the number 125, and the cube root of that is 5. Let's say I wanted to do the fifth root. Let's do here the fifth root of 243. On the calculator, I'm typing in the index first, math, choose number 5, type in the 243, and then I get my solution here, which is a 3. That's one way you can go about doing it. Another way that I like to show you all to use, and I'll show you first with the perfect cubed. In section 1, we don't talk about simplifying ones that are not perfect, but I like to go ahead and introduce this now so that you're going to become comfortable with it. What we will do is that we are going to, and we'll do a few that are perfect roots first. We're going to use on the calculator, we're going to go to y1 equals, we're going to type in the number that's the radicand divided by x, and the exponent, the number we put for the exponent, we're going to use the index value. Once we've done that, we're then going to do second table. We're going to press those buttons, second table, and we are going to look in the second column for a 1. If there is a 1, it is a perfect root. So let's do that example first. We just had the cubed root of 64. So let's do that one. If everybody will, go to your calculator and go to Y1. Clear out anything you might have there. and I'm going to type in 64 divided by x, and I'm going to raise it to my index, which was a 3. Then I'm going to do second table, and I'm going to look in the second column. Now notice we want to start where the 0 is, not with the negatives. So let me move this just a little bit for us. Okay, so you generally want to start when you have 0 here. I'm going to look in the right-hand column, and there is a 1. So this one is a perfect cubed root. The answer was 4. Go back to y equals, hit clear. We just had the fifth root of 243. So if you do 243 divided by x raised to the 5th power, we'll do second table. And if I look in this column, there is a 1, and the answer was a 3. Okay, let's go back to the square root. Let's say we had that square root of 100. So we could do 100 divided by x squared, second table, look in the right-hand column, and there is a 1. It's a perfect square root. It's a 10. So the first thing I want you to see is if you simplify and it does have the 1, it is a perfect square root, cube root, 5th root, 10th root, whatever root value you're doing. I'm going to come back to this page here in a few minutes, and I'm going to add some other bits of information, but I'm going to hold off on putting it there just yet. If you look in your workbook on page 8-9, we have the 5th root of 243 m to the 5th. We just did the 5th root of 243, and what answer did we get? The 5th root of 243 was the number 3. So that number would be a 3. For the m, it's raised to the 5th power, so 5 goes into 5 one time. So the answer for this is just 3m. Here I have the 4th root of 16y to the 12th. So I'm going to go to the calculator, go to y equals, and I'm going to do 16, clear, 16 divided by x raised to the 4th power. I'm going to do second table, look in the right column, and I find a 1. So it's a perfect 4th root. The answer is a 2. So the 4th root of 16 is 2. Now for the y, I'm going to say 4 goes into 12 3 times evenly. So that would be my simplified answer. Here I have the 5th root of a negative x to the 15th, y to the 5th. If you have an odd index, yes, you can have a negative answer. You cannot have a negative answer if the index is even. So since it's odd, we're going to have a negative. 5 goes into 15 3 times, and 5 goes into 5 one time. So my answer here is going to be a negative x to the 3rd and a y. Here I have the cubed root of negative 27x to the 21st. Okay, so let's come back here and let's check that out. And I'm going to use the other part since we've got the negative here. So if I do 3 math, choose number 5, and type in my negative 27, I'm going to get a solution of negative 3. Okay, so if the index is odd, I can still have a negative. So that's negative 3. And for my x, 3 goes into 21 evenly 7 times. If, however, I try to take the square root of negative 25, do the square root, negative 25, I'm going to get, it's a non-real answer. So back to non-real answer. So no negative solutions if the index is even. Yes, you can have a negative with an odd index. The reason is for every pair of negatives, it becomes a positive. So once you have that odd negative thrown in, then you can have a negative answer, a negative solution. Okay, let's continue with a couple more. Let's say we have the square root of x minus, writing backwards, of x minus 5 squared. If you're given something such as this, what it means is you have x minus 5 two times. Squared means twice. Since you have a pair of the same, it's going to come out from under the radical, and it's now just an x minus 5. In this module, there will be very little factoring. You're really going to get a break from that, but they wanted to give you one more of these. If we factor this first, it'll say factor first as a little reminder. So if we factor this, we end up with an x minus 10 and another x minus 10. So my pair of the same thing here is the x minus 10. So that is going to come out from under the bracket. If you have something written as a function, because you know we don't want to forget about function notation, let's say we have f of 11 equals the square root of 2x plus 3. This means, in other words, f of x. So we're plugging in 11 for the x. So that would be 2 times 11 plus 3. 2 times 11 is 22 plus 3. 22 plus 3 is 25. And the square root of 25 would be 5. So f of 11, the solution would be a 5. If you had something such as g of 2, it's like g of x, but we're going to plug in a 2, and we have 3x minus 8. This would give me 3 times 2 minus 8. 3 times 2 is 6. 6 minus 8 is negative 2. Here, we need to recognize that we can't have a negative under the square root. So for this one, the answer is undefined. It would be not a real number. Now, as you're working in section 1, you will have things that will be looking much like this. However, what I want to expose you to, which will be coming up a little bit later, but I want you to be somewhat familiar with, is going to be, and I promised you we would come back to this slide here. And let me add a different note here. If we find the 1, there's a perfect root. If there is not a 1, you are going to go where the 1 would be, then scroll up from there, looking for the first pair of whole numbers. Once you find that first pair of whole numbers, the left column is going to be the number that comes out in front of the radical. What's in the right column is going to be the value that goes up under the radical. That'll make sense in just a minute. I'll come down here and I'll give us a similar problem to do. Let's say we have, and I'll start with a square root. Let's say we have the square root of 300 x to the 5th and y to the 8th. If I wanted to simplify this, and if I were to do this longhand, let's say we're going to factor everything, because I want you to see what we're actually doing here. 300 would be 3 times 100, and 100 is a 10 times 10, right? So 3 times 10 is 30, and 30 times 10 is 300. We have a total of 5 x's, and we're going to have a total of 8 y's. So if I'm going to simplify this, what I'm looking for are pairs. I have a pair of 10s, so that means I have a 10 that's going to come out. I have 2 pairs of x's, so I have x squared that's going to come out. I have 1, 2, 3, 4 pairs of y's, so y to the 4th comes out. What's left under the radical is still the square root of 3, and there's an x. So if I took this and I needed to simplify it, it would be 10x squared y to the 4th square root 3x. Now, normally you're not going to want to write out all these variables. So what we would do is, the understood index is a 2. 2 goes into 5 twice. 2 times 2 is 4. 1, 2, 3, 4. There's 1x left. That stays under the radical. That 1, 3 here stays under the radical. For the y's, 2 goes into 8 evenly 4 times. There's no y's left underneath. So the variable part, you're just dividing the index into the exponent. However, let's look at that 300. Let's go to y equals, hit clear, and I want you to type in 300 divided by x squared. We're going to do second table. We're going to look in the right-hand column, and we're going to go down, and we're looking for a 1 in the right-hand column. Keep going, because we have to see if there's an exact 1. So there's not an exact 1. But what we're going to do, and if this will stop, I guess I tapped it too many times. We want to go to where 1 should be. The 1 would be between the 0.9 and the 1. So there's not a 1. I'm going to start coming up, and I'm looking for the first pair of whole numbers. It has to be the one closest down to where 1 would be. There may be other pairs of whole numbers, but they're not the most simplified. Like, do you see here there's a 5 and a 12, but wasn't there one earlier, the 10 and the 3? The 10, 3 is the simplified answer. If you bypassed it and kept coming up to one of the higher numbers, you would not have the most reduced answer. So, as I told you, the number in the left column comes out, the number underneath stays under the radical. Here's my 10, here's my square root 3, and I did not have to go about doing that longhand. Let me give another example. Let's say we're going to do the cubed root of, let's see, the cube root of 500 m to the 8th m to the 18th. Now let's not do this one longhand, okay? So we're going to take the 500 and do the cubed root. So go to y equals, we're going to do 500 divided by x raised to the 3rd power. Second table, we would scroll down, a 1 would be in here, My first pair of whole numbers as I go up is the 5 and the 4. The left column, the 5, is going to be the number that comes out from under the radical. The 4 is going to stay under the radical. I still have to keep the same index of a 3. 5 comes out, 4 stays underneath. And you have to choose the lowest one down, closest to where the 1 would be. Now with the M and the N, 3 goes into 8 how many times? 3 goes into 8 twice. 2 times 3 is 6. If you take 6 away from 8, you still have 2 more left. That's still less than 3, so there's still an M squared left under the radical. For the N, 3 goes into 18 evenly 6 times. 6 times 3 is 18. So that would be your solution for this. When you're using the calculator, not the calculator, but the keyboard on MyLabs Plus, there's two things that you're going to see. You're going to see a box where you can type in the square root. You'll see one that's just like that. Then there's going to be another one that has a square root, but what I want to point out is right here is going to be a little shaded box. This is the one that you would use if you were typing that in, because the 3 would go in the green box and then the 4m squared would go up underneath. Some people accidentally try to use the little box to raise something to a power and put it in front of this. Don't do that. There is actually a button, so you want to use this button on computer for indexes. We never put a 2. The 2 is understood for the square root. But if it's ever an index that's written, you would need to use that one. Okay, so that's just a little extra piece that's not covered in this first section, but it will be coming up as you start venturing your way forward. The workbook, the viewing examples do not show you this method, but I like to show it to you because I feel like it's easy and simple. Okay?